Hello friends, I was recently on an airplane and I thought to myself, wouldn't it be cool to get a video of what it's like when I'm speeding up and slowing down, dropping a ball, something. But I did have in my bag my charging cord. And so I was able to hang the charging cord and create a pendulum so that we can observe the acceleration of when we're speeding up and slowing down. And we can actually use these videos, I created shorts out of them, we can use these videos to calculate the acceleration of the airplane. So here's how it works. Now, first of all, here's the video speeding up in the airplane. And you can see that the pendulum is hanging back as the airplane gets faster and faster. So here we are as we're approaching the runway. We're about to make contact. And now, so that's it, we hit the tarmac and now we're slowing down. I had to just tap it to my leg to get it to stop rocking. But you can see how far out that's going. And I'm going to explain the physics behind that and how we can calculate the acceleration of the airplane just from the angle that the pendulum makes with the vertical. Okay, so here's how this works. Let's take a look first at the speeding up in the airplane. From where this is, right, I'm going to draw on here. I'm going to get a line along the pendulum. I get the auto straightening, which is helpful. And then I'm going to see now, see if I can get this vertical. And I'm going to measure what is the angle here. Okay, so I've got my protractor. I'll line this up. And it's looking to me like it's about 13 degrees. So I'm going to make a little diagram off to the side here. So I've got this vertical line. And then this line over here. Doesn't have to be perfectly to scale, it's just my diagram. So 13 degrees. Now what does that mean? Okay, so let's draw, if we draw a force diagram for the charger, right? I've only got two objects interacting with this. I have the cord, so this is F of the cord. Then I have the gravitational force, so Fg, or force of the Earth. And I know that this angle is 13 degrees. Right? Okay. The other thing I know is that this vertical component here, this, is equal to the force of the Earth. It's the force of gravity, because there's no vertical acceleration. Okay. Now this horizontal component, that is what's accelerating the pendulum as it moves forward. Okay. And so that tells me this is m, the mass of the charging block, times the acceleration of the airplane, because now this is what's keeping it up with the airplane as it's accelerating. Now, Fg is also equal to mg. Okay, so take a look at what I've got here. This angle, and then I have ma and mg. This is tangent, because ma is the opposite side, mg is the adjacent side. So I can write this. Tangent of the angle of theta equals ma over mg. And then if we look at that, the m's cancel out. So tangent of theta is equal to the horizontal acceleration over the acceleration due to gravity. So if I want to find the horizontal acceleration, all I have to do is take g times tangent of theta. I'm going to use g as 9.8. Go to my calculator, and I say 9.8 tangent of 13. I'm in degree mode, so that comes out to 2.26 meters per second squared. Or I can even just get rid of the 9.8, and that'll tell me how many g's there are. All right, so it's 0.23 g's. So A equals g times 0.23. All right, so in other words, what the horizontal acceleration is 0.23 times the acceleration due to gravity. That's how many g's we feel. And so But then with the 9.8 in there, it's 2.26 meters per second squared. Okay, and so that's what my horizontal acceleration was, roughly. Was the camera perfectly vertical? The core, is it being affected by, the coil I had at the top? Maybe, right? So it's an estimate, but it's an estimate that we can calculate as accurately as we can. But it comes out of this, right? This relationship, the tangent theta relationship, and then A is G tangent of theta. Now I've already done the work, so I can use this formula to calculate how quickly we were decelerating. And in physics, we still call this acceleration most of the time. All I need to do is find out what is this angle. So that's the angle of the chord. So now I draw a line straight down. I use my protractor, measure this angle. And this one is more. This one is looking like it's 18 degrees. Okay, and so the acceleration is G tangent of theta, where theta is 18 degrees. So that comes out to 3.18 meters per second squared. And that's 0.32 Gs. Thanks for watching. Don't forget to like and subscribe.